Hello, my dear students. This is your tutor, Mr. Richard Ayama. We are to continue with our lesson on educational statistics. And today we are going to deal with the most important distribution in statistics, the normal distribution. The normal distribution is at times called the normal curve or the Gaussian distribution. Now, mathematically, it is defined by the equation y equal to so and so. I think it will take long, so just observe how the equation is expressed. And this equation describes a curve, a bell-shaped curve. So here, looking at the equation, the x here is the random variable, the u is the mean, the population mean, the rho is the population standard deviation, then the pi is of value 3.14 and so on, and this, the e, the symbol like the e is called natural log of 2, which is of value 2.71828 up to. Then, when we convert the random variable x into a standard score, we will end up getting this whole equation in place of the normal curve. So, with this, we will say that the z is normally distributed with mean 0 and standard deviation 1. Now, symbolically, it is written as z is n into bracket open 0, 1, bracket close. But when you are talking in terms of the random variable x, then we say x is normally distributed with mean and variance of the population, which means that the random variable x has a normal distribution with mean and variance, as I've already explained. Now, in short, the whole thing describes this graph. Now, this curve is the y equal to so and so, and then the horizontal line is the z scores. Now, when the area bounded by this whole curve and the horizontal axis, when you multiply the curve, the length of the curve by the horizontal axis, you get a total area of 1 and nothing else. Now, don't forget here, we didn't label the horizontal axis x because it is assumed that the x random variable has been converted to standard score. I think you already know something about the standard score. Now, let's look at the properties. Let's look at the properties of the normal distribution. The normal distribution is curved. The normal distribution is curved, which is of bell shaped. Now, if you are to go back, if you look at, when you look at the diagram, you can see that this curve is of bell shape. Hence, that property. Now, let's look at the second property. The graph is symmetrical about the vertical axis through the mean. Now, let's go back to the graph again. You can see that there's a vertical axis as the pointer is indicating. Now, when it is folded, the whole graph is folded along the vertical axis, where u is equal to 0, you end up getting half of it fitting on the other half exactly. So when it happens like that, we say it is symmetrical. We say it is symmetrical about the vertical axis through the mean. But here the mean is 0. Now let's go to the third property. It says the mean, the median, and the mode are equal. If you remember the shapes of histograms, we came to realize that there were 3 different types of shapes. We have the positively skewed, the negatively skewed, and the normal skewness. Now we said that one of the properties of the normal skewness is the mean, the mode, and the median are always equal. The same thing applies here. Because this is a normal distribution and it indicates the nature of a normal graph, the mode, the mean, and the median are equal, as we said earlier. Now let's move on to the fourth property, Let's move on to the fourth property. It says it is a unimodal distribution. That's the normal distribution is a unimodal distribution. What do we mean by it's a unimodal distribution? It simply means the normal distribution can only have one and only one mode and nothing else. Now let's move on to the fifth property. It says it is completely determined by the parameters mean and then the standard deviation. Different normal distribution is specified for different values of the mean or the standard deviation. Now, what do we mean by this? Whether the normal distribution will vary or not, whether it will change in the shape will enlarge or not, will always be determined by the variance or the mean. In other words, the standard deviation or the mean. I hope you know the variance and the standard deviation, they move hand in hand. It's the square root of the variance, which is on the standard deviation. So in this case, we can use them interchangeably. Now the point is, in case there's a little variation in any of them, either the mean or the standard deviation, it can also lead to what? A little variation in the nature or the shape of the distribution, the normal distribution. Now let's move on to the sixth property. It says the curve approaches the horizontal axis asymptotically in either direction away from the mean. Now, what do we mean by the curve approaches the horizontal axis asymptotically away from the mean? Now, if you look at the curve, the normal curve, you see that as soon as the curve is approaching the horizontal axis, it will not touch it, but it will turn in a curving nature and be moving along the horizontal axis. It doesn't touch it, but it moves along the horizontal axis. The same thing applies to the other side. When it happens like this, we say it is approaching the horizontal axis asymptotically. Now let's move on to the seventh property. Say the total area bounded by the curve and the horizontal axis is equal to 1. I think this one I've already explained why it is equal to 1. we use the principle of calculating the circles, the area of a circle. You see that when it is a semicircle, so this normal distribution curve is more or less like a semicircle. So when you multiply by the curve, the length of the curve, by the horizontal axis, which is assumed to be the radius, you end up getting the total area being 1. Now let's move on to probability of random variable x under a normal distribution. Now if we are talking of probability, that's the probability that a random variable will fall within a specific range in the normal distribution curve. So let's look at this example. Say the total area bounded by the curve and the horizontal axis is equal to 1. The area under the curve between two ordinates, that's when x is equal to a and when x is equal to b, where a is less than b, represent the probability that x lies between a and b, statistically denoted by p of a less than x and x less than b. Now, when x is converted to the z-scores, then generally we obtain a standard table indicating the various volumes, the various areas of the corresponding values of y, corresponding values of z, indicated as p of z less than or equal to z, small z. Don't forget, the capital Z here is the random variable or the z-score for the population value. And then the small z here is the z-score for the sample value. And as you know, we always use the sample value to estimate the population value. So with this, I think when we solve some examples, you understand. Now this is the Z distribution table or the standard normal distribution table. It normally ranges from negative to positive. Don't forget, earlier on we said the Z values range from negative 4 to what? Positive 4. The same thing is applied here. But each table, it depends on what the person wants. It's not all the time that they start from negative 4 to positive 4. Some may, for maybe lack of space or one way or the other, they may start, like in this case, it started from negative 3.6 to negative positive 3.6. That's the positive aspect of the table. Now I think you understand the whole thing better when we try to deal with some examples. So let's deal with some examples. So let's deal with some examples. For example, you've been given Z. If Z is normally distributed with mean 0 and standard deviation 1, find A, probability of Z less than or equal to 1.5. B, probability of negative 1.97 less than Z and Z less than 1.32. Then C, probability of Z greater than 1.86. So I want us to take these examples one by one. I want us to take these examples one by one. Now let's move on to the first example. Now you can see that normally in labeling the numbers, it starts from what? The left to the right. If you remember the principles of the real number system, we say on the number line, any number to your left is smaller than any number to your right. So this principle is being applied here. So it means if we are being told that the Z value, don't forget, the horizontal axis here is scaled the Z. So the Z value here is 1.5, but we are being told that the probability that the Z value is less than or equal to 1.5. That means the shaded region here is where the Z value will lie. So we have to find the corresponding area of this shaded region. And how is this done? You first go to the normal distribution table. It is, the value we are looking for is 1.5. So you come to the first column, that's the leftmost column, which is headed by Z. Now when you go down till you come across 1.5, as the pointer is indicating. Then if we are to continue, it should have been 1.50. So it means we move on horizontally to the adjacent columns. And since the next value after the 0.5 would have been 0, we move on to the column headed by 0.00. 0.00. And then we read the corresponding number found there. And this one we get 0.93332. Zero point 0.9332. That means that the probability of Z less than or equal to 1.5 is equal to 0.9332. Now let's move on to the second problem or the second example. That we are to find the probability of Z lying between negative 1.97 and 1.32. Now from the diagram, you can see that right from here to this side, is the area of, that's the area cut off by the Z less than or equal to 1.32. And from the leftmost on the diagram to the first vertical axis indicated with negative 1.97 is also the area covered. So if you want to find the probability that the Z falls within this region, then you have to subtract the area covered by the negative 1 point, Z equal to negative 1.97 from the area cut off by the 1.32. So with this, it will give us the shaded region. Hence, we are going to get mathematically to be the probability of Z less than or equal to 1.32 minus the probability of Z less than or equal to negative 1.97. Now with this, we now move on to the table, the normal distribution table, and read the individual or find the area bounded by or cut off by these values. So let's first go to the normal table and deal with the probability or find the area bounded by the probability that Z is less than 1.32. B2 is positive. We consider only, since 1.32 is positive, we consider the positive aspect of the Z. So we look at it from the Z distribution table, that's the normal distribution table. We trace it down, the values of Z, till we get to 1.3. 1.3, and this is what the pointer is indicating. Then you see that the digit that follows the 1.3 is 2. So we then trace it horizontally to the column headed by 0.02. 0.02. And we read the value that intersects with that column. And that one will get and we will get the probability of Z less than or equal to 1.3 to be equal to 0.9066. Now let's go back to the table and read from the table and determine the area bounded by the Z less than or equal to negative 1.97. Now this time, since it is negative, we will only deal with the negative, we will go to the negative side of the table. Now with the negative side of the table is negative 1.97. So we trace it till we get to negative 1.9 on the Z distribution table. And here this is negative 1.9. Then you see that the digit that follows the 0.9 is 7. So we trace it horizontally till we come to the column headed by 0.07. And that one, the value there is read 0.0244. 0.0244, meaning that the probability of z less than or equal to negative 1.97 is equal to 0.0244. This means that we are going to substitute this all the values into the equation. That's the equation shaded by the given by the shaded area. And with this, you end up getting probability of z lying between negative 1.97 and 1.32 to be 0.9066 minus 0.0244, which we will end up getting 0.8822, and that's the probability of the z falling within this region as indicated in the diagram. Now let's come to the third example. We are to find the probability of z greater than 1.86. Now from the diagram, the normal distribution diagram, we know that from the leftmost to the rightmost will give you a total area bounded, total area of 1. So if we are being told that z is greater than, we are being told that we are to find probability of z greater than 1.86, then from the graph, this is how it will be. So right from here, let's say this is the mean. Of course, it's a z-score, so this is the z-score. This is the mean, and this is 1.86. We are being told that the z value or the area we are looking for is that area should correspond to an area which is greater than 1.86. So in effect, this will be the region. This will be the region of z, this will be the region of z greater than 1.86. This is the region. Now we are being told the total area of the curve is 1. So it means right from here to this will give us a total area 1. So if from here to here is the region that is 1.86, that corresponds to the z-score 1.86. Then if you are finding the area or the region which is greater than this, then that will be this place. So it's a matter of subtracting the region from here to here. Don't forget, the normal distribution table will always give you the area from left to the right. And this time we are looking for the area on the right. So the best thing we have to do is what? We first find the area from the left to the right. Then we subtract it from the total area under the normal distribution curve. And that will be and that will give us probability of Z being greater than 1.86 to be equal to 1 minus the probability of the area that lies on the left side. So that will be probability of Z less than or equal to 1.86. So this probability of Z less than or equal to 1.86 is in correspondence with this region. So when we subtract this whole region here from the total area bounded by the curve, we will end up getting this region. So what we only need to do is we go to the normal distribution table and read the area that corresponds to what? This. And that will be the probability of Z less than or equal to, back to the slides. You can see that this explains what. Now let's go back to the slides. So when we read from the table, as usual, as we did earlier, you first go to the Z column. Then you trace it down till you get to the 1.8. Then you trace it horizontally till you get to the column headed by 0.06. And the corresponding value that will be read is 0.9686. So what it means, we are going to subtract this 0.9686 from 1, and that is what is given here. In effect, we will end up getting 0.0314, which means that the probability of Z being greater than 1.86 is equal to 0.0314. Now let's look at a noted point here. They said the above solved example deal with the case where Z has been converted to Z. You can see that the example that we worked, we were dealing with the Z value, Z greater than, Z less than, or Z falling between. But it's not always that it will be the case. At times you will be dealing with a random variable X. In that case, the way to solve it is different. That means that one, if we are to look at the above example, we were lucky the Z has already been, the X, random variable X has already been converted to Z. So that one we didn't have much problem. But this time, if you are rather given the X, that's the random variable, then we have to bear the problem of converting it to what? The standard score before we can read it from the normal distribution table. Hence, we deal with the case where X has not been converted to Z. We call it arbitrarily normal random variable. That the Z is the arbitrarily random normal random variable. So when it happens like this, then normally the probability of this is the standard score of the population, and this is the standard score of the sample. So in effect, we will end up getting the capital Z, which is the population standard score, less than or equal to the sample standard score, which is small x minus the population mean divided by the population standard deviation. And in all this, it is assumed that the Z is normally distributed with mean 0 and standard deviation 1. And with this, we can now be comfortable to read the value from the normal distribution table or the Z distribution table. So example, given x, or if x is normally distributed with mean 2 and variance, don't forget when you are dealing with a random variable, the second entity here is normally the variance, not the standard deviation. With variance 16, find A, probability that the random variable x is less than or equal to 3. B, the probability that the random variable x lies between 1 and 4 inclusive. That's 1 less than or equal to x and x less than or equal to 4. Don't forget, when it means the endpoints are inclusive. Then C, the probability of x greater than 5. Then we come to the probability D, the probability of x equal to 2. Now let's solve them one by one. The solution. Now you can see that here with the random variables I said, it is rather the second entity in the bracket is the variance. And when we want to deal with the Z, we must, don't forget, for the Z score is always divided by the standard deviation. So we must find the standard deviation, not the variance. So in this case, since the standard deviation is the square root of the variance, we take 16, the square root of 16, and we end up getting the standard deviation 4. So what it means is that in all our denominators, we are going to deal with the what? 4. The 4 is going to be our denominators. So with this, using the theory above, we can go ahead and use it to solve the distance. So you can see that, then you can say that the probability of x being less than or equal to 3 will be equal to, first, this will be the population. So this capital X here is the population standard score. So it will be capital X minus the population mean divided by the population standard deviation. And that will give us the population standard score Z. Being less than or equal to the sample random variable, which is x, minus the mean 2 divided by 4. In effect, we will end up getting 1 over 4, which in decimal fraction, we will get 0.25. So it will then be read as probability of Z less than or equal to 0.25. So with this, we go to the standard normal distribution table. Then from there, from the Z column, we trace it down till we get to the value 0.2. Then we trace it horizontally till we get to the column headed by 0.05. That's the 5 here. Then we read the corresponding value. And from there, we will get 0.5987. So, the probability of x being less than or equal to 3 is equal to 0.5987. Now let's come to the second question. We are to find the probability of 1 less than or equal to x and x less than or equal to 4. Now with this, substituting in the values. So here with the 1, that is the sample random variable, that is 1. So it will be 1 minus the mean, which is 2, divided by 4. And you end up getting negative 1 divided by 4. Then this is the population z-score. So that one we use the capital X because we don't know that one. We don't know the population random variable. So we use capital X, and that will end up giving us the population standard score Z. Then the same way on the on the rightmost, we will have 4, that's the sample random variable, minus the mean divided by 4, which we will end up getting, so this is supposed to be it's supposed to be 1 over 5, 1 divided by 5. Oh, sorry, it's supposed to be 1 divided by 2, not 5. 1 divided by 2 and not 5. So with this, you end up getting the probability of negative 0.25 being less than or equal to z, and z less than or equal to 0.5. That's 1 divided by 2 is 0.5. So with this, we read from the table. When we are to express further, we will get this to be, so with this, when we calculated, we ended up getting probability of negative 0.25 be less than or equal to z, and z being less than or equal to 0.5. So with this, diagrammatically, this is what we are going to get. Sorry. Of course, with the standard score, the mean is always 0. So this is the z. So what happens is that this is negative 0.25. So the negative 0.25 will fall on the left side of the 0. So negative 0.25. Then the 0.5 will fall on the right side of the 0, which is 0.5. So we are looking for z falling between these two values. Hence, this will be the region where the z is to be. So what do we do? As we did earlier, the probability of negative 0.25 be less than or equal to z, and z be less than or equal to 0.5 will be equal to the area from here to here minus the area from here to here, and that will give us this region. So it will be the probability of Z being less than or equal to 0.5 minus the probability of Z less than or equal to negative 0.25. Then from the normal distribution table, we first try to read the value of 0.5. So what do? We go to the Z column, we trace it down till we get to 0.5. I say there's no digit after the 0 point, means the digit there is 0. So you trace it horizontally till you get to the 0, the column headed by 0. And the value there is read 0.6995. Sorry, it's rather 0.6915. Then the same thing is done to the probability of Z being less than or equal to negative 0.25. So with this, we traced from the Z column on the normal distribution table. When we trace it down till we get to the negative 0.2, then after locating the negative 0.2, we then trace it horizontally till we get to the column headed by 0.05. Then we read the corresponding value there, and that one will be 0.04 0413. So when we subtract 0.4013 from 0.6915, we will end up getting 0.2902. So the probability of X being or the probability of X lying between 1 and 4. I want you to study how the C and then the D aspect of the question is solved by following what the way it has been solved. So I want you to go and master it and come next time. Now with all this, we want to find out how this is applicable in the educational sector. That's how do we apply normal distribution with all this. We want to know its essence the normal distribution, the essence of the normal distribution in educational statistics or in our educational field. How is it applicable? It can be applied in two main aspects. First, you may be asked to find the probability of a situation occurring in the educational sector, of a situation occurring. All this can be solved by using. So let's deal with the given examples. These are some of the practical implications. First, question 1. The ages of some students in a school are normally distributed with a mean of 12 years and a standard deviation of 4 years. What percentage of the students are between 8 and 14 years old? B. At most, what percentage of the students are at most 10 years old? Or what percentage of the students are more than 9 years old? Now with the solution, it means the random we are dealing with a random variable here. So we need to convert the random variables to the z-scores before. So if you take the first situation, we say that let x years denote the age of students chosen at random from the school. Meaning the x is normally distributed with the mean 12 and the variance 16. Don't forget, we were given the standard deviation here to be 4. So in the case of random variable, we have to convert it to variance by taking the square of 4, and that gives us what? 16. So with this, we are to find the probability of 8 being less than x and x being less than 14. That's the probability of the student falling between 8 to 14 years. And with this, when we substitute the values, we will get probability of 8 minus the mean, that's the random, the sample age, 8 minus the mean 12 years, divided by the standard deviation 4. Then the capital X here, don't forget, is the population random variable. So when we subtract the population mean, then we come to the left, the rightmost. It will be 14 minus 12 divided by 4, which will end up getting 0.5. So what we do is that right from what we did from the beginning, in this case, we will subtract the probability of z being less than 0.5. Oh, sorry, you will subtract the probability of z being less than -1 from the probability of z less than 0.5. And by that, we will get this expression. So now we go to the table. Reading from the table, I think we've already read probability of z being less than 0.5. And that one we had 0.6915. Then from the table, the probability of z less than -1, we will also get 0.1587. I hope by now you've mastered how to read from the table. So substituting into this formula, we will end up getting 0.6915 minus 0.1587, which is 0.5328, meaning the probability that a student or a people selected at random will fall between the years 8 and 14 is equal to 0.5325. Then in percentage wise, it's a matter of multiplying the probability by 100%. So by so doing, you will get 53.23% of the students falling between 8 and 14 years old. Now let's deal with the second one. The probability of a student being less than 10 years, less than or equal to 10 years. When you substitute it as usual, you will get this whole expression. Then we will end up getting the z being less than negative 0.5. Then from the table, as we've been reading, you will end up getting 0.3085. So in percentage wise, that's you multiply the probability, this value, the 0.3085 by 100%, which you will end up getting 30.85 of the students being at least 10 years old. I leave the C aspect for you to go and master it. Of course, if there's any problem, you let me know. Now let's look at another situation in the educational sector. We can also apply the normal distribution in the situation of placement. So an example is as follows. Scores made on a placement test by JOSCO students are approximately normally distributed with the mean of 25 and the variance of 64. What percentage of the students were placed in the science class if a student must score more than 40 in order to be placed in the science class? Then B, what percentage of students were placed in the social studies class if a student must score between 20 and 35 for this offer? Then C, the percentage of students who will be placed in the ICT class if a student needs to score at most 29 for this offer. I hope I'm not being biased towards the ICT and the social studies class. Now let's look at the solution. As usual, we have to define our random variable, which is x. So we say let x be the score of a student selected at random from the candidates. So this implies that the random variable or the score of the student is normally distributed with mean 0 and standard deviation 1. So with this, if we are to find a student, don't forget, we are being told that before a student will be placed in the science class, he must score more than 40. So in this case, we are to find the probability of x greater than 40. And for that matter, you end up getting probability of trying to convert it to standard score. It will be probability of z being greater than 40 minus 25 divided by 8. Lest I forget, don't forget, since this is a random variable, the variance must be converted to standard deviation before we can use it. And by so doing, we had the standard deviation to be 8. Hence, the denominator being 8. So we will end up getting, with this, we end up getting P being equal to Z greater than 15 divided by 8, which will be P, that's probability of Z greater than 1.88. And don't forget, I told you, whenever it is greater than, you always subtract its corresponding value of less than or equal to from the total area, which is 1. So the corresponding value of less than will be probability of Z being less than or equal to 1.88. And now from the normal distribution table, from the Z column, you trace it down to, you get to 1.8. Then having located 1.8, you then trace it horizontally till you get to 0. The column headed by 0.08. And the value that will be read there will be 0.9699. So when we subtract 0.9699 from 1, we will end up getting 0.0301. So that is the probability of a student scoring more than 40. And that means the probability of the student being placed in the science class. So in percentage wise, we multiply 0.0301 by 100, and we will end up getting 3.01% of the students being placed in the science class. Now let's come to the third situation, the second question. We are to find the probability that a student is being placed in the social class. And we shouldn't forget that we were told the student, before a student is placed in the social class, that student might have scored between 20 and 35. So with this, we find the probability of a student scoring 20, which will be 20 minus 25 divided by 8, less than the Z score. And the Z score being less than, the population Z score. And the population Z score being less than a student scoring 35 minus 25 all divided by 8. So in summary, we will end up getting negative 1.25 being less than Z and Z less than 1.25. Then with this, we subtract the probability of Z less than negative 1.25 from the probability of Z less than 1.25, which we will end up getting. So then we go to the normal distribution table. Then for the probability of Z less than 1.25, we read 0.8944. And the probability of Z less than negative 1.25, we will get 0.1056. So when we subtract this from 0.8944, we will get 0.7888. Now percentage wise, of course that is what the question is being demanded for. In percentage wise, When you multiply 0.788 by 100%, you get 78.88 of the students being placed in the social studies class. I leave the C aspect for you to go and master. Now let's look at the third example. This also with another situation. That the marks obtained by JOSCO students in educational statistics end of semester examination are assumed to be normally distributed with mean 57% and standard deviation 15%. Find the percentage of students who had grade A if the minimum mark for grade A is 80%. B. What proportion of students scored B if the mark for grade B must be between 69% and 79%? C. Find the percentage of students who were referred if the maximum mark for referral is 49. I think this whole question is almost in line with the ones we've already solved. The only technical issue is that of the P. We were to find a proportion, but not percentage. When we say the proportion, it's the same as the probability value that you get. It's the same as the probability value that you get. That is the proportion. So that is how it is. Now I want you to go and try the following. I want you to go and try the following. If Z is normally distributed with 0, with mean 0 and standard deviation 1, find the probability of Z being greater than or equal to 0.56, and the rest follows. You come to the second aspect, that one, it is in the case of the random variable x. That means you have to convert it to z-score before you use it. Then we come to the question 3, that one deals with the practical implication. That the IQs of individuals admitted to state school for mentally retarded are approximately normally distributed with mean 60 and variance 100. Find the proportion of individuals with IQs greater than 75. Then B, find the probability that an individual picked at random will have an IQ between 55 and 75. I want you to go and try and master them. In case of any difficulty, you let me know. My dear students, this comes to the end of today's lesson. I hope you've enjoyed the lesson. And I will also encourage you to keep on practicing. And you will never regret. Stay blessed. Thank you.